Try from this figure to find out the standard form of the ellipse. So the standard form of the ellipse, if we are looking at this distance d1 plus d2 is equal with 2a. The a, it means is the distance in major axis from this position here to this position. So, and let me write this formula here. d1 plus d2 is equal with 2a. So we are looking from this, we are going from this equation. And now, so just let me look a little bit. But the distance formula, we already know, is equal, d is equal with, let me write here general formula for the distance, is x2 minus x1 squared plus y2 minus y1 squared. So now I'm using this formula. But instead of d1 here, we are looking here the distance here. So let me take the radical. And here is x2. So x2 is x minus c, but because I have two minuses, become plus. So I have x plus c, and this is squared. Plus, instead of the y here, coordinate y minus 0. Here is 0y. Y minus 0 to the focus. Y minus 0 is a square. And if I'm going in the distance d2 here, it's going to be x minus c, so the x coordinate, okay? And this is the x minus c square, plus if I'm going to the y coordinate is a y minus 0, so this is y minus 0, and everything here as we have this equation here is equal with the 2a. And now if we are going further, now let me put this one with the radical in the right side, but when I move in the right side I'm going to change this, so I'm taking a shortcut, I'm going to change the sign in the front. But first of all, let me leave this radical here in this side, okay? So if I'm leaving this in this side, it's going to be x plus c squared plus y minus 0 is a y. Let me write here y squared. And in the other side here is 2a. But this one I move into the other side is a minus. Okay, but now this x minus c, I write in the same way how it is. I cannot do anything, but here I can do something. So this was squared. Y minus 0 is just a y, and it's a y squared. And I don't have anything else, okay? So everything here I'm going to square. If I'm squaring everything, so let me square this side here, and I'm going to square this side here, everything. So this square here with the index is going to simplify. What remains inside remains just x plus c squared. So let me write x plus c. Okay, so let me do one extra step. Plus y squared is equal. And now this one I'm going to expand. If I'm expanding this here, 2a is going to be 4a squared. Is a minus 2 times the first term times second term is a time of 2a times the second term is x minus c squared plus y squared plus the second term squared. If I'm squaring the second term, everything is going to remain just the radicand. And here is going to be x minus c, everything here is squared plus y squared. And now I'm going to distribute everything. Okay, I'm going to expand everything. So let me move one. Let me move further. If I'm expanding this one like with quadratic formula, with a binomial formula, I have here the first square plus 2 times first term, second term plus the second term square. Okay, so the first term here is x squared plus 2cx plus the second term square is plus c squared plus y squared, and this is equal. So let me write here 4a squared, and this one I can do nothing, but I can do here 2 times 2 is 4a, so this is 4a, this is good. And everything here stands at the same, x minus c squared plus y squared. But on the other hand, here what we are expanding, this one is going to be plus x squared minus 2cx plus c squared and plus y squared. And we are looking what we have at the same term in the both sides. We can eliminate it because we can cancel, because for example I have y squared minus y squared this side minus y squared this side is going to eliminate. So in other words, whatever I have at the same term I can cancel. For example, x squared with the x squared in this side can cancel, c squared with the c squared cancel, y squared with the y squared cancel, and I'm looking what do I have else. I have this one plus 2cx. Let me go to plus 2cx. So this one cancelled, but I'm adding here plus 2cx. And this is going to be 4cx. Is equal with the 4a squared minus 4a everything here x minus c squared plus y squared. Okay, now I am in a better position now to find out. But now everything, if I'm dividing by 4, so the 4 is going to eliminate. If I divide every time by 4, what's going to remain is going to remain, for example, in this side, cx. But in this side is a squared. If I'm putting it the other side, it's going to be minus a squared. And this is equal to the minus a. So imagine here I was divided by 4, all the terms, okay? And this a squared I put in the other side, that's by is negative a squared. In the other hand, here I have x minus c squared plus y squared. And now everything I'm going to square again. And what do I have here? I have a cx minus a squared. Everything here is in square. And this is going to be equal. And if I'm squaring here everything, x minus c squared plus y squared. Okay, everything squared. Okay, so let me go quickly here. Let me go quickly. So this one, what I'm going to have here, I'm going to have a c squared x squared. And this is a minus 2 times a squared cx. A squared cx. And the plus is a in the fourth. Okay, this is very good. In the other side, minus a times minus a is a squared. So that's what's going to happen. But here, everything is going this is going to simplify by this, okay? So what I'm going to have, x minus c squared. But let me distribute this one. Let me expand. Is x squared minus 2cx plus a c squared plus is a y squared. But this a is going to multiply everything inside. So let me do one extra step here, okay? But just let me change the color because I went too far with the same color. So let me rewrite c squared x squared minus 2a squared cx plus a in a fourth is equal. Here I am going to distribute a squared x squared minus 2cx a squared plus a squared c squared plus is a y a squared y squared. That's what I have here. But you see this term is the same with this term here. I can eliminate. But now I'm looking here, I have a x squared. So, and this is a a4. Okay, this is a a4. So, what do I have here? a4. Let me leave a4 in this side. a4. But this a squared, c squared. So this one I'm putting other side and it's going to change the sign. It becomes a squared minus c squared. But this is a a4 was. So just do not forget, this is a a4. I'm sorry. But now, so this one I am done. This one is eliminated. C squared x squared I'm putting in the other side. It's going to be negative. And I'm looking to put near this one here. A squared, okay, x squared minus c squared x squared. So, and this one I'm done. And this one I'm done. So what remains else here? What remains else remains this plus a squared y squared plus a squared y squared. But do not forget here, according to the Fosse, we have this formula b squared is going to be equal with a squared minus c squared. So this formula now I am applying here inside. But before that, let me just factorize here something. If I'm factorizing here 1a squared, what's going to happen here? Let me write here. A squared, what remains here? A squared minus c squared. Am I correct? Because if I'm multiplying by square, I'm getting this here. On the other hand here, I have a x squared. So this x squared I'm going to do with a squared minus a c squared. Okay? And I have a plus a squared y squared. But now, whenever I have a squared minus c squared, I'm going to replace by b squared. And in this side here is going to be a squared b squared is equal x squared b squared plus a squared y squared. And now here I'm going to let me go. This is the last step. I'm by the end here, but just let me go a little bit further. Okay, so I'm last step. What I'm going here to do, I'm going to divide everything by a squared by square. Let me divide everything here. A squared by b squared. Every term, a squared b squared, and here a square b square. So what I can do here now, so this a square I can simplify, b square I can simplify, but here everything simplifies. What remains here? Here remains 1 is equal, is x square over a square, is a plus y square over b square. So here is the end, and we already proved the formula for the ellipse.